Hey, this is another video about getting the Arduino and TouchDesigner to talk to each other. In the last video, I showed how you can get some analog input like a potentiometer to have its value sent over from the Arduino to TouchDesigner and just show up here in the text box. So I've got a different setup now where I actually have a voltage divider with a light-dependent resistor. And the way that I've got it set up, whenever you hover over the light-dependent resistor, you get a higher number. So you can see here, I'm hovering over the sensor and the number is going up in the upper right there. And then when I move away, it goes down. So what I would like is to have a slightly more complex example. I've got 3 of those set up on pins A0, A1, and A2. And I'd like to essentially just not really look at the number that's coming across, but send whether or not it's covered. So I want these 3 separate ones to be to show up as either covered or uncovered in TouchDesigner. So how do I do that? And how do I do that in a way that is maybe a bit clever? In our example before, what we did was we read the sensor value using analog read, which of course gives us a number between 0 and 1023. But you can see these numbers go, they're in a much smaller range, and they're all kept in a single byte. We're sending a single byte of information over, and a byte can only store a number between 0 and 255. Let's look at how that works. So here's a single byte. There are 8 bits in a byte, and they start on the rightmost side there. That's bit 0, then bit 1, bit 2. And so each one has its own place. This is kind of like if you look at the way that you look at decimal numbers, right? There's a ones place, a tens place, a hundreds place. That's how you tell what this number is. It's 6,700,000,000, 3 10 millions, 1 million. That's a weird way to say it, but you get the idea. I think the way this works is each place this is the 10 to the 0 place, which is the ones place, the 10 to the ones place, that's the tens place, the 10 to the twos place, which is the hundreds place. And if you look at the way decimal numbers work, it's the same thing, except instead of being based on tens, it's based on twos. So the 2 to the zeros place is 1. See, that's the equivalent of 1 in decimal numbers. The 2 to the ones place is the twos place. So now we've got both of them turned on. That equals 3. 2 to the twos is 4, and then 8, 16, 32, 64, 128. So if all of the bits in this 8-bit byte are turned on, then we get a number that's 255. If they're all turned off, then we get a number that is 0. So that's where we get this range of 0 to 255. And if we turn on like a single bit, we can see that we get some random number between 0 and 255. And so this is how within 8 bits of information, 8 ones and zeros, we can represent any number between 0 and 255. So what we're doing here is once we get that number between 0 and 255, we write it. We don't do a serial print, because serial print, if the number was 127, then we are sending over with print the characters 1 followed by a 2 followed by 7, and then presumably some separator, because if it was just 127, 127, 127, we wouldn't know where one number ends and the next one begins. So you'd need some kind of separator, usually like a new line, which is like hitting enter on the keyboard. So now we're talking about 4 bytes for one single number, where the way we're doing it is we're sending that single byte over the serial port. So the number 127 is just encapsulated in that 1 byte of information. That's the difference between write and print. So I think we talked about this last time, but over here in TouchDesigner, what we're getting is we have a serial DAT, and with that, we get this serial callbacks window that shows up. And basically, this function on receive gets called every time a byte of data comes over. And so again, this is simpler because we're just reading a single byte of information in and responding to it, versus collecting bytes of information and trying to figure out where one number, one string of characters stops and the next one begins. This is very simple. It's just a single byte. So again, can we do this with our 3 photosensors? Can we just have 1 byte of information that encapsulates everything? That's our goal. So the first thing I'm doing here is I'm just changing that byte of data to an integer, and I store it in this variable called integer. And then I just set the text of this text op I created over here, text dat, and I just set its value to whatever the integer is that came in. So you can see as I hover over it, the number changes. Now, what are these letters over here? Are these characters? Sometimes there are other things besides letters. So what this is, basically there are, for each of the letters or numbers or characters that we would normally type into a keyboard or transmit information, in a text file or over a serial port or something, there's a numeric equivalent of it. So this is called ASCII. This is an ASCII table that shows all of the different characters and then the number that's associated with them. So back in TouchDesigner, we can see like right now when it's stable and it's just kind of sitting there with I think the reason why it's going up and down is because I have LED lights in here, so they're always kind of flickering. But we get a lot of W's in there and some M's. So let's look back at this chart. So M, we look over here and see M in the decimal column, it's 77. So if we look back over in TouchDesigner, you can see every time an M shows up here, there's a 77 that shows up over there. So it's basically showing you the decimal equivalent. Now, why sometimes does it show a dot? Well, let's see. This is like 160 or something. So let's look back over here in the ASCII table. Well, it doesn't go that high. So 160 or something like that is not really anything that we'd be able to visualize. And also the low numbers over here are not anything that we can visualize either. Escape, I think there's like carriage return, form feed, things like that, bell. Those are not actual characters that we'd see on screen. So there's kind of a limited range of things that'll actually show up over there. And so this is the same thing that you'd see in the, if you were to open the, what do they call it here? The serial monitor. In the Arduino, it would show similar things. So not useful unless you're able to, set something like this up where we're taking those individual bytes and converting them to integers and then showing them here. Again, if we didn't do that, if we just showed the byte data instead, what we get is a byte, like a different representation of it, which is, in this case, is just showing the letter. So that's not helpful for us. So we'll go back to integer. There are our numbers. Okay, so back to the problem at hand. How can we get a single number between 0 and 127, or sorry, 0 and 255 to represent the state of these three sensors? So let's look again at an example here, the bits in a byte, right? So let's say the first sensor is represented, whether it's covered or not, is represented by this bit. And then the second one is represented by this bit. And the third one is represented by this bit. So this means literally if all three are covered, then we get the number 7, right? So, and what if only the outer two are covered? Then we get the number 5. So there is a unique number associated with all of those possibilities, right? So here's just the first one being covered, and then here's none of them being covered. So we can use this. We can use the bits here instead of worrying about what they equate to as a decimal number. We can just look at this as a map, like a kind of a table, like an Excel spreadsheet, right? Like each one of these bits actually means something rather than the whole byte meaning something. So let's see how we can do that. First, we need to kind of rearrange the Arduino sketch, which I think is going to look like, basically, I'll try and simplify this, but we don't really need to worry about the pin names, but we've got sensor 0 value. We're going to read that in. We don't need to set these to 0. The default is 0 anyway, so I'm just trying to minimize this. I think this came from the Arduino example. So here, setup, we don't change anything. That just configures the serial port for us. And then over here, we're reading in the value. For sensor 0, we're going to read in from A0. And again, we're dividing it by 4 to get it to be within the range of a single byte. And then I'm going to do the same for sensors 1 and 2. And they're on A1 and A2. And then what we'll assume is that we want to have a byte that is starts at 0, but we'll manipulate the bits within that byte in the same way that I just showed you. And then we'll eventually write that byte out to TouchDesigner. So if I do this right now, I think if I just save and upload this to the Arduino, we probably won't get, okay, we've failed because over here, the Arduino serial port is already in use. So let me turn this off and then try that again. And then when I turn this back on, we've got, let's see, behind here, we've got 0. So that's all we sent was 0. Okay, so this is working. Something, I was able to upload. It's always worth a little sanity check. So the thing I want to do here is check to see if sensor 0 value is greater than some threshold. Let's make a variable for that. Threshold equals 100. And we could say if it's greater than that threshold, then we want to set the 0 bit of our output byte. Now, if if you're watching this and you know a lot about writing code, you probably are like, well, why is it an int? Because int isn't an 8-bit type. It's fine. In Arduino, people use int all the time. There is actually a way to have a variable that is only a single byte, but it really doesn't matter in our case. We're not trying to be efficient here, just trying to make it readable. So the 0 bit of that output byte. So we want to set that. When we either say set or clear. Those are the terms that we use. So we don't have to say set it to 1. We just say set it. So how do we do that? This is interesting. This is where bitwise math comes in. And so let's look at this calculator. I'll send you the link to this in the description, but it's cut off here. But this is a nice kind of example of how this works. So let's look at how bitwise math works. First of all, let's just switch the operator to OR. So we have different operators, and this is Boolean math. This is the same kind of logic. Boolean logic is what's used in kind of philosophy and other areas besides writing code. But we can say OR, and what's happening here is here's a byte, right? It's all the 8 bits of a byte. Let's say it started out as like these 2 bits are on. Well, if we combine that byte with another byte using the OR operator, let's see what happens. So let's see if we can make some conclusion about what's happening here. This 1 or this 1 equals 1. This 0 or this 1 equals 1. This 1 or this 0 equals 1. And then 0 or 0. So one thing is you could kind of look at this as 0 being false and 1 being true. So for example, in this first one, an apple is red or a banana is yellow. Well, those are both true, and we've said only one or the other has to be true, so the answer is true. Over here, we could say an apple is red or a banana is red. Right. Well, there are red bananas. Yeah, so I'm struggling to find a color that doesn't work for a banana. How about this? An apple is red or a banana is a grape, right? Like this is true or false. Only, as long as one of them is true or the other, then we'll get true as an answer. Now, and is different. They both have to be true. You can't say an apple is red and a banana is a grape and get a true value. So that's basically how these operators work. What's useful to know is if we want to set a bit, let's say we start out with all zeros, and we want to set a given bit, we can combine that original value with or the OR operator and the bit we want to turn on, and that's what we get in the end. Now let's say this first one is actually the number 16, right? This bit is on. Well, all we've done by combining it with using OR is that we've kept the original bit and we've added a new one. So this is really useful. It's a way to just flip bits on and off using Boolean math. Okay, so let's just translate that over to our Arduino code. It's going to look like this. The output variable is equal to whatever it was before, and this single pipe is the OR operator. Combine that with 0B0001. This is the same thing I just did over here in the browser, right? So it starts at 0, let's say, and 0. So because we're only interested in the last 4, we're not going to be venturing into these leftmost 4. We can just use 4 here, but the right way to do it, I guess, maybe would be to put all 8 digits there. But this works. So that's all we've done here. We've just turned on bit 0, the first bit on the right, we've basically set that bit on this variable. Okay, so let's do the same for the other 2. So we've got sensor 1, and we're going to set the 1 bit. And the way we do that is just to do this. And then the last one is sensor 2. And we want to set the 2 bit, or the third one from the right. And it's going to look like this. So that's it. I'm going to save this. I'm going to go over here and make sure this is the serial port's turned off, and I'm going to zap this over to the Arduino. Okay, it doesn't like something. Expected a semicolon. Okay, used to using other languages these days that don't require semicolons. Okay, let's turn this on, see what we get. So we've got a 0. If I cover the first one, I get a 1. If I cover the second one, I get a 2. If I cover the third one, I get a 4. And if I cover the last 2, they combine to be a 6. Why is that? Well, one more time, we'll look over here. We set this bit, and then we kept going, or well, I guess the last 2, right? I set this bit, and then I also set this bit, and so you get 6. So what we've got, again, is just these last 3 bits are telling us everything about the state of those 3 different sensors. Okay, so now what? Now we need to do something over here, something more interesting than just showing the numbers. So let's see what that looks like. I'm going to make this bigger, turn the parameters back on. And what I want to do is I'd like to change this code to basically, well, let's actually figure out what we're going to do here. So I want 3 circles. I want to have the 3 circles represent the 3 different light sensors. And I think maybe I need, how do we do this? Let's add a transform. Did that work? No, it didn't work. Okay. I want to transform for each of these 2 because I want one to be on the left side and one to be on the right side. Let me just highlight these, and I'll do a couple of things. One is I'll just change the resolution to be something higher so they look better on the screen. And then I'll also go here and change the radius to be much smaller. And then when I transform them, I want this one to be a little bit over to the left and this one to be a bit over to the right. Whoops. Over to the right. I don't have to change the middle one. And then what I'll do is I will add a composite here to put them all together. And I'll make sure that's an add operation. Let's see. This is another place where Boolean math appears, is actually here. Add, subtract, those are Boolean operators. So here they are, all 3 of them. Now what I really want is, let me add one more thing, which is a constant. A constant, and I'll make it a black color, and I'll just add that to my composite. So I've got a black background, and then I'll just do this so we can see them all in the background. Now, some people find that annoying, but I like to see that there. It's just helpful for us. Okay, so I'm going to come back over here and look back at the code that's here. And I think the easiest way to get these to show up or not show up is to change the alpha. So if I change the alpha of this one, you can see the one on the left disappears. So if I could set this to 0, that would turn it off. If I could set it to 1, that would turn it on. So I'm going to look at this, and this is where I think I can be a bit tricky. So I've got the integer, and what I want to do is, first of all, just again, a sanity check. I want to say, can I change circle 1, look at one of its parameters. Which parameter? Well, let me hit the plus sign over here. It's called fill alpha. So fill alpha, and I'm going to set that to like 0.4. So it's working, right? Every time a byte comes in, it sets the alpha of this one to 0.4. So that's good. So instead, let's set it to, well, let's look one more time. I guess there is one more time at the Bitwise calculator, right? So if I instead use the AND operator, what does the AND operator do for me? Well, given some number that's coming in, let's say I covered the first one and the third one in, and the Arduino sent over this number 5. I want to see if one of those is on. So if this is the one, I want to check to see if this one is on. And if it's on, I get a 1 in return. What if this one is on? Do I get something? Well, no, it's not on, so I get a 0 there. What if this one? So what I'm getting is like if I get either, well, one way to look at it is to say I either get a 0, right? A 0 if there is not a match, or I get something above a 0 if there is a match. Okay, so I'm going to say, let's take the integer that we got in and do an AND operation and compare it to a binary number that has a 1 in the first place. Okay, so let's see what happens. Okay, well, it disappeared. That's interesting. Why did it disappear? And if I cover this thing, it comes back. That's interesting. So, and if we look over on the right side where it has the alpha, you can actually see it's going from 0 to 1 when I cover it. Okay, so that's interesting. So let's try this for the other two. So here's circle 2 is going to be that bit. Circle 3 is going to be that bit. Let's change these for the other two circles. Let's see what happens. Okay, they're all off, and then I cover them, and they do come on like they're supposed to. So this is working. There are a couple details here. One is, there's something more to this. Like if I click on circle 3, let's say, and I cover that one, if you look, alpha is actually 4 over on the right, which works for us because I can make alpha 6000. If it's 1 or more, it's going to be fully on. So we're cheating here a little bit by giving it a 4, because remember, if you look at the website here, if I check for number 4, it gives us a number 4 back, not an on or off or a 1 or a 0, which is what alpha typically expects. But we're just kind of cheating, and it's letting us cheat because you can put in whatever number you want here. Just to prove that, I can put in the number 500, and it comes on, but it immediately went off because this is redefining it. But it does work. It turns it on if it's anything above equal to or above 1. So this is working just fine. Now the only detail is it does seem to be backwards. Like I want it to actually show up when I take my hand away, right? Like I want it to be black when I cover it. And it's actually doing the opposite right now. So we're going to do another cheat, which is to say in Python, true and false are the same as 0 and 1. And actually they're the same as 0 and not 0. So anything that's not 0 is the same as true. It's not the same for all languages, but I think that's true for Python. So what we're getting here is we're getting the number 4 in this case, but that's the same as true. And so true and false, a 1 and 0, these are binary things, and those work with Boolean operators, and not is actually a Boolean operator that says whatever true, false, 1, 0 value we have, flip it. So if I put a not in front of these, what happens is it actually translates each of these to, I think, to a 0, because it says this number is actually a 4 in this case. That returns a 4, and if I say that's the same as any other number that's above 0, then when we flip it, the opposite is going to be 0. So it's a little crazy, but I think let's see which one are we highlighting? 3. Let me hover over it. So it goes 0, and then when I let go, it goes to 1 now. This is interesting. This is an interesting trick. We're tricking Python. But this is kind of a hack, but it's working great. And I like how elegant it is. But, the thing about bitwise math and digging into the bits within bytes, I would say, it really is in the realm of like making things more efficient. There is some elegance to it, but sometimes it makes the code less readable. This isn't as understandable if we did kind of a long drawn out version that we could read that looks more like English. So I would say, adding comments here is helpful if you're doing some foolishness with individual bits, but it is very convenient for us that we're able to send 1 byte over just constantly, 1 byte every 10th of a second, and get exactly the response that we need. So it's worth considering. And I would say, always making it readable and understandable to you and others is definitely like the primary way to think about writing code, unless you have a real requirement to make it super efficient, which we don't for something like this. So there's something clever about this, though, and just sending 1 byte of information feels good. And as long as you can understand what's happening here, then great.